1 minute to start. Did you divide yourselves into group of 2 in the lab, or no?
You still need a microphone. Okay.
Okay, so I recommend you to. Okay. I really recommend you to divide yourselves into groups to think together, okay, as the pre-lab and the lab questions may be little more difficult than that we have in the lecture. This is because I divide you into group of 2, so you have 2 brains to think together, to look together, to search together, okay, to make analysis, to design together, okay. So you are not only alone, you have a teammate and you must work together, okay. As at the end, when you submit the lab report, you will write your name and your teammate name on the same report, okay. So you must collaborate.
So only one report.
You will submit 1 report in the campus. In your, yeah, but everyone has to submit his report. But for example, if you are the teammates, you will submit a report, the same report as the report that he will submit, okay? And on the same report, you will write your name and his name, okay? So I recommend you to collaborate, so to achieve the best results, okay? I want to start. Yesterday, I remembered that in the last year, I received a call from one of my friends. He told me that he applied for system administration engineer job at TELUS, and he was rejected during the interview. Okay, and he told me that I was doing well. I answered the most of questions. Okay, but the interviewer asked me one question, and after this question, he finished the interview. Okay. What was this question? The question was, the interviewer asked him, we are now working on a project in TELUS to design a network for hospital. And in this hospital, we want to divide the network into 4 sub-networks, okay? And we have IP range, but no one answers this question until I finished, okay? The IP range 200. Okay, this is the IP range that we have, okay? And during the project, we make IP subnetting using fixed length subnet mask, okay? And based on the fixed length subnet mask, we want to divide this network into 4 subnetworks. Okay, so we will modify the subnet mask from the default mask to, we want to have 4 subnets. So 2 of n equal 4 subnets, n equal 2, and n is the difference between the new mask minus the default mask. So 2 minus 24, so the new mask is 20. And after making subnetting, we divide the network into 4 subnets, and each subnet has 62 valid host ID. But at the end, we face the problem that there is a failure in the network. What is the reason of this failure? What is the wrong in these steps? And again, it was a true story. So again, you are given IP address, okay, and the network operator require from you to make subnetting to divide the main network into 4 subnetworks, and using fixed length subnet mask, we already divided the network, okay, into 4 subnet masks. So now each device in the network has an IP address, so they can communicate now. But after doing this, there was a failure in the network. There was error message. Okay.
First octet is 260.
What is wrong?
It's greater than what you can store. You can only go from 0 to 255.
This is the correct answer. Okay. So the trick, the trick was in the given IP address. The range that we have for IP version 4 is from 0 to 0 to 0 to 0 to 255, 255, 255, 255. Actually, we don't have IP start with 260. Okay, we can't have this, as we have 32 bits. And if we have all of these 32 bits are all ones, we will have 255.255.255.255. So this was the trick. We don't have 260. Okay, so there is 1 mark bonus for Daniel. Yeah.
Sorry, yeah.
Daniel.
No.
No. No, sorry again. You're
Sorry.
What?
Sorry.
No, okay, thank you. Okay.
Yeah.
Okay. Don't worry, I will record it. So in this lecture, we will give 1 mark bonus for Daniel. Okay. This was an interview question. Okay, so please focus. And it is very easy. Okay. Okay. Let's return to our lecture. Okay, in our previous lecture, we discussed together that we have classful IP addresses, class A, B, C, D, E, and the last IP address is 255.255.255.255. Okay, and each class has different network portion and different host portion, and can serve different number of hosts. So class A is used for very large networks. Class B can be used in medium networks, and class C can be used in small networks. And class D, we use it for multicast transmission, and again the multicast. We are here a group of students in the same class, in the same session. If I want to talk to this side only, I will give them multicast IP address. Okay, so I can talk to them at the same time. Okay, so multicast, we have unicast transmission is 1-to-1. My device is speaking with Duncan device. So this is 1-to-1 communication. It is called unicast. We have multicast. One device is talking with group of devices. We have broadcast. One device is speaking with all devices. Okay, this is a difference between unicast, multicast, and broadcast. Okay, and the class E is reserved for subnet, for experiments. Okay, and we discussed together that classful IP addressing is not efficient, as we are wasting IP addresses. Okay, if I want to design a network consists of 10 devices and another network consists of 12 devices, I still have to buy one IP range slash 24 here and one IP range slash 24 here. Okay, so I am wasting my resources. So we suggest to use IP subnetting that enable us to create multiple logical networks under the same main network. And this will help us to make better management of traffic and improve the network security. And we have two types of subnetting: fixed length subnet mask, where all subnets are of equal size with an equal number of host IDs. So here in the previous example, we want to divide the network into 4 subnets. Each subnet has equal number of hosts as in all other subnets. Okay. Today we want to discuss another type, which is variable length subnet mask. Different subnets can be of different sizes. Each subnet can have different number of hosts, different number of devices. And this is actually what we have in the real life. Here, the network of engineering department for sure may need different number of devices that are different from the devices required in a financial department or sales department. So how can we make variable length subnet mask? This is the topic of our lecture today, and we discussed 2 examples about fixed length subnet mask. Okay. And this is a table, and you have a homework at your home to construct the fixed length subnet mask class B table by yourself. I recommend you to do it. So, okay, today I want to discuss with you how to make variable length subnet mask addressing or subnetting. Okay, let's discuss together this example. We have a network. This network consists of 3 local area networks. LAN 1 with 25 hosts, LAN 2 with 55 hosts, LAN 3 with 12 hosts, and also we have link A and link B and link C. Okay, I want to ask you at first a question. How many subnets do we have in this example? Can you say them?
Router 1, 2, 3, and then link ABC, if I'm not mistaken.
Okay, so instead of router 1, 2, 3, LAN 1, LAN 2, LAN 3. Okay, as LAN 1 is connected to router 1. Okay, and LAN 2 is connected to router 2, and LAN 3 is connected to router 3. Okay, and these all routers must be connected together. So router 1 is connected to router 2 through link A. So link A at the end will need IP address on this interface, and the IP address on this interface. And router 2 is connected to router 3 through this link C. So we must allocate IP address on this interface and IP address on this interface. And router 1 is connected to router 3 through this link B. So we want to allocate IP address on this interface and IP address on this interface. Why I need to allocate IP address on these interfaces? Because each interface in the network must be allocated an IP address to be able to communicate with other devices. Okay.
Why is that? Why isn't there a way that we can use port numbers to link between routers instead of?
Yeah, you want to use port numbers. Okay. Actually, we included in your bucket. The bucket includes the source IP address, the destination IP address, and the port number is also included in that destination.
If we ensured the port numbers were like different for each link, couldn't we use the same interface on one?
No, because each interface in the router represent different network. So we have a router here. This router is connected to this network. And there is another network here. Okay, so this interface and this router belong to LAN 1. At the same time, this interface of the router belongs to LAN 2. So these two interfaces are on the same router, but each one belongs to different network. Okay, so each interface on the router must represent new network. So in our case here, we have, so this interface must be on a different network from this network and this network. And also this interface must be on a different network than the other network connected to this router. This is why, because I will need it in the routing. In the routing, I will determine what is the best way that packets can take from source to destination. How can we make routing? We make routing through IP addressing. I will look to your IP address, and based on this address, I will select the way that I can take to reach to your destination. Okay, so part of my routing is to select which bus should I take. Maybe there is a router here. Okay, so I can, and there is a destination here. This is your destination device, and this is your source device. The source wants to communicate with the destination, and we want to make a routing. We can reach to this destination through multiple ways. One way is to take this way, and another way is to take this way. So how can I determine which way is the best? As routing is selecting the best way to reach to the destination based on the IP addressing. The IP addresses on your way or on your path to reach to the destination. Okay, so I still need IP address here and IP address here to use them in the routing process in data routing. Okay, this is clear for you? Okay, so we have 6 subnets: LAN 1, LAN 2, LAN 3, LAN A, LAN B, link A, link B, link C, and we want to make IP plan using this IP range. You are given 192.168.4.0/24. So this is class C IP address, okay? And using variable length subnet mask, which means that each network will have different number of hosts. So I want to allocate to each network sufficient IP addresses that can serve the different number of hosts in each or in each subnetwork. Let's see how can we do it. Actually, it is very easy problem. If you follow the steps, I confirm that you will have the correct answer at the end. Okay, so the first step is to arrange the networks from the largest to the smallest. Can anyone help me to arrange these networks? 2, 1, 3, A, B, C. Okay. If I take B, C, A, it is wrong or not?
Absolutely.
Oh. if I take B, oh, he says that A, B, C. Yes, in the order. So A, then B, then C. If I say that C, B, A, this is wrong or the same?
Still valid.
Yeah. Okay. So yeah. So it's correct. Our first network is LAN 2. Second one is LAN 1, LAN 3, and link A, B, C. No matter the order of A, B, C. Okay. So this is the first. Arrange the network from the largest to the smallest. After that, we will make subnetting for the largest network at first. So we will start with LAN 2. LAN 2 has 55 hosts. So we will start from the first IP address in the network. The first IP address is 192.168.4.0. This will be the subnet or network IP address for subnet 1. Okay. After that, we will calculate the number of hosts. This is given for us. We know that the number of hosts is 55. 55 must equal to 2 power h or n minus 2. And we want to calculate the number of bits allocated to the host part. Okay, so 2 of h or 2 of n equal to 57, and we can approximate it to the nearest 2 power number, so it will be approximated to 64. So h equal 6 bits. So the number of bits allocated to the host part is 6 bits. What about the number of bits allocated for the network part? Okay, can anyone?
Will that be 26? Oh, 32 minus.
How will you calculate it? So you will subtract 32 minus. Yeah, sir. Okay, so as 32 is the total number of bits of the IP of the IP. Okay, so we have 32 bits, and from these 32 bits, we have 6 for the host. How many remaining bits for the network? Yeah, 20. Okay, so the new subnet mask is, instead of having 24 subnet mask, which is the default subnet mask for class C IP address, we will have 26. Okay, so this is your new subnet mask, and you can write these 26 ones in this form. So 255, 8 ones, 255, 8 ones, 255, 8 ones. We still have 2. The first 2 ones can give you 192. Okay, so okay.
Can you explain where the minus 6 came from again? I missed that.
This step.
Yes.
Okay, so you are given the number of hosts that LAN 2 needs to have. So we have 55 hosts, and as we know, the number of hosts is equal to 2 of each, 2 power number of bits allocated to the host part, and we subtract 2 IP addresses, as one IP address will be for the network part address, and the last one will be reserved for the broadcast address. So from this step, we have 2 of each, where each is the number of bits, of host bits. Okay, 2 of each is equal to 57. Okay, we must approximate this number to the nearest 2 power number. So the nearest one is 64. Okay, so based on this, the H is equal to 6 bits. Okay, and we have the total number. The total number of IP address is 32 bits. Okay, so we calculate the new subnet mask, or the subnet mask is the number of bits allocated to the network part. Okay, so we have 32 bits, and from these 32 bits, we have 6 bits allocated to the host part. How many remaining bits for the network part? So 32 minus. Okay. Okay. So now we can calculate the network address for the next subnet. How can we calculate it? Okay, add the number of hosts plus the network address and the broadcast address. Okay, so add all of the IP addresses in the network one, which will equal 2 power 5. Okay, so we will add 64 to this IP address. So we will have 192.168.4.0 plus 64 will equal 64. How can I calculate the broadcast address for the first network?
60, add 64, subtract 1.
Yes. So I subtract. The broadcast address is the last IP address in your network, subnet network range. So we know now the IP address of subnet 2. If we subtract 1 from this IP address, we can get the broadcast address. Okay, so the broadcast address is 63. Okay, if I want to know the range of the valid host IP addresses, can anyone tell me what is the range of the valid host IP addresses in this network?
1 to 63 or 1 to 62?
1 to 62. Okay, so all of the IP addresses between .0 and .63 are your valid host IP addresses. You can allocate these IP addresses to your hosts. Okay, so the range of the valid host IP range in subnet 1 is from .1 to .62. Okay, so as a summary for this, the first subnet network, the network IP address is the first IP address, and the broadcast address is the last one, and any IP addresses between the first and the last one are valid IP addresses for the host. Is this clear for you? Okay. Okay. At the lecture uploaded in the Canvas, I think there is a problem. There is a mistake here. This was 1. No, the correct is 4. I deleted this file and uploaded a new one where this correct is. Okay, this mistake. Sorry, listen. Okay. I need one of you, and also I will give him 1 mark bonus to make that submitting for the next network. Can I have any volunteer here? Okay, so based on we finished the submitting for LAN 2. We need now to do the submitting for LAN 1. We need 25 hosts. So now LAN 1, 25 hosts. And we start from subnet IV, subnet to IV equal to okay. So, and we have any volunteer? Okay. Can you join me?
Try, I guess.
Where is my mask? And you can take a different pen if you want.
So start up. And then you have six.
Can you explain to your friends
Broadcast the
how can you get this answer?
this /27 because we need 32 is 2 to 5 because we have 25 hosts, and then we use the next network from this one to be the broadcast, or the broadcast down here. This one's the other one, and then you need the 30 range, 32 minus 2 between them.
Okay, so this is your network address.
Yeah, broadcast and this host networks.
This is the broadcast.
Yeah.
And this is your host number. Okay. So I think you have one mistake.
Does it start at 65?
This is the network number.
Yeah.
The network number is correct.
Okay.
64. This is the first IP address. Okay. Can anyone? Okay.
192.168.4.64 is your next subnet.
So this one will be the IP address of this.
That'll be WAN 3, and then 6 or 9.5 will be your broadcast.
9.5 will be the broadcast, and the valid IP host range
6.5 to 9.4.
to 9.4. Okay.
Okay.
Okay. So do you understand how can we get these results? So again, so your name? Daniel. You are Daniel. And he's Daniel. Okay, sorry for that. And Ross. Okay. So I need a paper. One mark. Daniel. Daniel, I will give you 0.5 mark on as there is a mistake here. And I will give you also 0.5 as. Okay, so how can we get it? We start from the subnet network IP address. We have now 192.168.4.64. How can we get it? We get it from our previous step in making subnetting for our first network. So we are now in the second network. Okay. And okay. We know that number of hosts is equal to 2 power h minus 2, and number of hosts here is 25. Okay, 2 of h will equal to 27, and we will approximate it to 32. So each will be 5. So we have 5 bits reserved for the host part. So our new mask, which means that the number of bits allocated to the network part will be 32, the total number of bits of IP address total number of bits for IP address minus 5 will equal 27. So the new subnet mask is 27. Okay. I want now to determine what is the next subnet mask IP address and what is the broadcast address. To calculate the next IP, the next subnet mask IP address, the next subnetwork IP address, we will add all of the IPs in this network. So in this network, we'll add 2 power 5. Okay, so we will add 32. So we will add 32 to this IP address. When if we want to add 32, the new IP address will be 192.168.4. 64 plus 32 is equal to 90. Okay, so if I want to calculate the broadcast address, I must subtract 1 from this IP address. So the broadcast address will be .55. And any IP between the network address and the broadcast address is your valid host IP range. So from .65 to .94 are your valid host IP range. Okay, so this is the answer of subnetting second largest network. After that, we will make subnetting for the third largest network, following the same steps. Okay, so here we have in LAN 3 12 hosts. Okay, so we can approximate them to 16. So number of bits allocated to the host is 4 bits, and your new mask 32 minus 4 will be 28. Okay, and I will add 16 to power 4 to the subnet mask. So I will add here 96 plus 16. It will give me 112. This is the IP address of your next subnet mask. Subtract 1, it will be your broadcast address, and any IP between 96 and 111 is valid IP addresses for you. This is clear. This is okay. I want from you to train yourself. Okay. So Daniel on the board, he didn't go through all of these steps. He made all of these steps inside his brain, and in few seconds he was able to answer this question. Okay, as in the interview, you will not say to your interviewer, please give me a paper and a pen, I will make my calculations. No, subnetting is a very quick question. When I ask you, if you are giving a certain IP address, I want to know how many subnets, you must give me an answer within few seconds. Okay, you must think about the question and give me a quick answer. Okay, you don't have to wait to make steps, as it is, you can do it in your brain. Okay, so IP subnetting is a very important topic that you must train yourself to solve their questions or solve its questions in very fast, very few seconds. Okay, as all of the interviews, if you want to get a job in system administration, engineering, or network operations, for example, in the interview, there will be at least one question about IP subnetting, as it is a very important topic in the communication networks. Okay, so we will follow the same steps to make subnetting for link A. We have 2 hosts only. Okay, and here in this example, as you can see, we start from dot 112, and our broadcast address is dot 115, and we have 2 hosts only in the network. One will be to the first interface, and the second one will be to the second interface. So all of the IP addresses allocated to this network are utilized, are used. Okay, as you can see, we have only 4 IP addresses: 1 for the network, 1 for the broadcast, 2 for the 2 router interfaces. Okay, this is clear for you? Okay, and we will make for link A, link B, and link C. Okay, so this was the variable length subnet mask addressing. Do you have any question? Okay.
Why wouldn't you, for the 3 routers, put them all on the same network? Why would you do a separate network for each set of links?
No, in each link, it is already in separate network, not all in the same network.
But why would you do that? You could say 2 IP addresses because then you would have, if you used
So if we turn back,
like a 29.
okay, so this is the links. Okay,
Yeah.
you want to allocate them to put them in the same network.
Yeah, what's the advantage of doing separate networks for each link rather than having them all share the same network?
Okay, I bought them in separate networks as I will use it in the routing. If they are all one network, I will deal with them as one way. I will go through network. For example, we have here network LAN 1, and here we have LAN 2, and there is a source here, and there is a destination. Okay, and I want to go from source to destination. Okay, and I want to determine my way from source to destination. If all of these routers belongs to the same network, I will deal with them as one way. So my way will be through this link and through this network and through this network. What about the way through this network? How can I determine the best way that I can take? Okay, this must be done through IP addressing. So this network must be different from this network, because the probabilities, the link speed, the link delay, many of the network parameters in this link are different from this link, Okay, so I want to differentiate. I want to know how I can know which link is better to take to reach to the destination. If they are in the same network, I will not be able to see all of these network parameters. I will deal with them as one network, as one link. No, this is not practical. In the practical, I must determine. I will take this link, not this link. Why? Because this link its speed is faster, it has minimum delay, for example. Okay, so how can I take this decision if this link, if I am able to determine the probabilities of each link? How can I do it? By making each link a different network. Because at the end, okay, you will, in the routing table, there is a routing table. This is your map. Okay, if you want to go to source destination, you open Google Map and write the source and destination, and it gives you the way to the destination. Okay, and the router also has routing table. The router will record the name of network. Okay, not the name of certain link. No, in the routing table. We have a router here. This is a router. Inside the router, there is a routing table. There is a table, okay? Source, destination, and the bus, and exit interface. This is the routing table, okay? So in the router will not record the IP address of each source. No, the router will record the network address, okay? So here we have something, we made something for LAN A, LAN 2, LAN 3. And LAN 1, LAN 2, for example, has 25 hosts. The router will not record the IP addresses of the 25 hosts. No, the router will record only the network address of LAN 2. So here, LAN 2, okay? And the same, for the destination, the router will not record the IP address of all hosts of LAN 1, for example. The router will record the network address only for LAN 1. So this is LAN 1. For the link, the router will take, okay? The router also following the same, will record the network address of this link, not the IP address of this link, okay? So it will record, for example, network address of link A. And how can I reach to this way? It will record its exit interface. So the routers can have many interfaces. Fast Ethernet, for example, serial, it depends on the technology that the router uses. Sometimes serial links, fast Ethernet, Giga Ethernet, okay? This is physical types of the links that can be connected to the router. It will record that, for example, through Ethernet 0x0. As in the router, the number of the interface 0x0, 0x1, 0x2. If we have second row, it will be 1x1 and go on. Okay, so the router interfaces will be in this way. So this is 0 and 1. So 0x0, 0x1. You understand it? Okay. So this is the routing table inside the router. So the routing table is dealing with the network addresses, not the IP address of certain source and a certain destination or certain link. Okay. As imagine if the router is dealing with the IP address of each source and IP address of each destination and the IP address of each link. What is the size of this routing table? It will be very, very large. Yes, as in practice, we are dealing with many networks with huge number of hosts. Okay, so if the router is dealing with the IP address of the host, of certain host, and IP address of certain destination and IP address of certain link, the size of the routing table will be very large. So I need huge memory resources to be able to save this routing table. Also, the router must take a decision in few seconds, not few seconds, few part of seconds. Okay, if I give you table consists of 5 rows and told you based on this table to select the best way to take from source to destination, you will have a look in these 5 rows, and based on these 5 rows, you will give me a decision. Is this correct? What if I give you routing table consists of 1,000 rows? You will need more time to give me a decision. This is correct or not?
Yeah.
Yeah. So no, we need the routing to be done in few part of seconds. Okay, in 5G, we want the latency to be less than 0.1 millisecond. In 4G or 3G, it was less than 1 microsecond. Okay, so we want to minimize the latency. We want to minimize the time that the router take to give me a decision. So that's why we are dealing with network addresses. Okay, and that's why we need to make each link in a network. Okay, to make the router able to determine the properties of each link. Okay, and to deal with each link as separate network to use it in the routing. Okay, and to minimize the number of IP addresses saved in the routing table. Okay, is this clear for you?
Yeah.
Okay, and you must. No, there's no time. Okay, we have only 2 minutes, but to make it clear for you, if the router is dealing with the network address, how can at the end we reach to the final destination to specific device? So the router responsibility is to deliver this is the source and this is the destination. The router responsibility is to deliver your data from the source to the network of the destination, not to the destination. Okay, now your data is with your router in your network. So your router, okay, is connected with you at the same network. Okay, the router will see based on your IP address and based on his IP address or its IP address. Okay, it will know that yes, we are connected in the same network. Okay, how can I reach to you? This will be through the MAC address. Okay, so the MAC address, each packet, each frame contains IP address and the MAC address. And as I told you, the MAC address is for each device is unique. Okay, no one can have the same MAC address. So based on when the router look to the received data, it will see destination address, network address. Okay, we are in this network, but I want to forward this data to certain destination. Or based on the MAC address, you are connected with me in the same network. You have unique MAC address, so this is Dunkin' data. I will forward it to you. In the next lectures, we will know how the router can know the MAC addresses of the connected hosts with it on the same network. Okay, this is clear for you. Anyone has any question? Anyone had any question? Okay, where is Thomas?
Right here.
Yeah, Thomas, you are late to submit your assignment one.
Let's do tomorrow.
No.
Perfect. Tonight. What was it for this morning?
Yeah, you can. You still can submit it. Okay, but
Yes.
I will give you a little penalty for the first time. Okay.
Sorry, I look at the agenda. Probably close the time.
Yeah, no problem. Okay. So anyone? Okay, so we finished our lecture today. If anyone has any question, feel free to send me an email. Okay, and again, we have office hours every Tuesday from 12 to 2 p.m. And on all other weekdays, you can send me message and can make me at any time. Okay. Okay. Have a nice day. Thanks. I also uploaded some of problem sets for IB submitting with solutions also. You can have a quick look.
Thanks.
Okay.